So with applications of trig, we're still limited as far as applications that we can do, because the only trigonometry that you know right now is right triangle trigonometry, but we can still do some stuff with it. And we'll build on it later. Okay, a dog 18 feet away from a tree is watching a squirrel climb straight up a tree trunk. At one moment, the angle of elevation from the dog's eye level, 2 feet from the ground level, is to the squirrel is 48 degrees, and then a few seconds later, it's 76 degrees. How many feet up the tree did the squirrel climb in those few seconds, and how far from the ground is the squirrel? So, let's draw the situation. We got a dog 18 feet away from the squirrel climbing up a tree. Okay, so we got a tree. Do you remember this? Tree. And squirrel. Okay. Let's do dog first. So dog. Dog's only 18 feet away. Whatever. Okay, cool. So the dog's that's a dog. Well, you know, it is what it is. Okay, so the dog eye level is what? Two feet from ground level? Okay. No. Do you want to scoot up closer? No. Okay. Do you want to sit on that side though, so I'm not like behind you? Okay. All right. So dog is 2 feet for ground level. The squirrel is at one moment. Oh, and the dog's 18 feet away from the tree, right? Okay. So 18 feet. At one moment when it's looking at the squirrel, it's 48 degrees. So 48 degrees is a little bit more than just half. Okay, so we'll say at one moment this is 48 degrees, and here's the squirrel. The squirrel's blue, I guess. Cool. And then a few seconds later, it's 76 degrees. So, and we're going to assume the squirrel is in the same distance away. Cool. So now this angle, let me do a different color for that one. Okay. So at that moment, this is 76 degrees. Okay. How many feet up the squirrel did the, how many feet up the tree did the squirrel climb in those few seconds? So what are we trying to find? From. There you go. Okay, how many feet up the tree did the squirrel climb in those few seconds? And then how far from the ground is the squirrel, right?
Wait, what's the dog's eye level? I thought it was to the squirrel.
No, the dog is eye level. It's just saying 2 feet from ground level. And then the elevation to the squirrel is 48 degrees.
So the portion below the triangle doesn't matter?
Well, it doesn't matter in the triangle setup. It does matter in the final question, which is how far up from the ground. Cool? All right. So what can we do? So we can think of these two triangles as two separate triangles, right? What do we know about those triangles? I don't know if they're similar. I do know some things about them, right? I know that they're right triangles. I know that this, what's this base length? How much? That was 18. Yeah? Okay. So 18 feet away in both cases. What else? True, but as far as like those triangles, that's the 2 feet is. Okay, the angle, good. So we know that this is 48 degrees. And we know this is what? 76 degrees? Okay. What can we do?
We know we can get the last angle.
Oh, we could get the last angle. What are we trying to, like, what's our goal, though?
We're trying to solve for the opposite.
Right, we're trying to find that distance. Aren't we trying to find the difference between these two heights?
Yeah.
Okay, so could I find this? And then could I find this? And by finding those, find the answer?
Yeah.
Okay. So, how do we find x?
So we know we're looking for opposite.
Okay.
We have adjacent.
Good. We're looking for opposite. We have adjacent.
That's a tangent.
Mm-hmm.
Degree.
So tangent of
48.
equals.
X over 18.
Okay, and then how do we solve for x?
Inverse.
Just trying to solve for x, right? You only have to worry about in.
By 18 on both sides.
There you go. Yeah, that's it. You only have to worry about inverse if you're trying to find an angle. Because an inverse outputs an angle. All right, so what mode do we need to be in?
We're not looking for an angle.
Right, but we're typing in an angle inside a trig function, and that angle is in degrees. So we need to be in degree mode. So I'm going to say 18 times tangent of 48. So times by 18, times by 18, and I end up with 19.991. 19.991 what? What unit is that? Okay. So that means that's this distance, right?
Yeah.
Okay. Now what do I do?
Do the same thing for 76.
Okay. So same thing, but with 76 degrees. So tangent of 76 equals y over 18. Y equals 18 times tangent of 76. And I get 72 point, ooh, my scale is really bad then. 194. Oh, that was terrible. Feet. Okay, so that's this length. So what am I finding now? The difference between them. Okay, good. So if I were to take these two and do, oh, I wrote 7. It's 72. That's, anyway. Okay, so y minus x equals 72.194 minus 19.991. 72.194 minus 19.991. And I get that distance between the squirrel climbed at 52.203 feet in those seconds. Cool. Okay. Now as far as like accuracy goes, I wrote down 3 decimals because that's what I've been telling you guys that I want you to do. But if you grab the 2 and you subtract them, you still get the same answer. Good. Okay. I didn't worry too much because both of them ended up with like zeros after, so they wouldn't round up. But if it had like 0.99 18 or something like that, I might have written out 4 or 5 decimals, so that was correct to 3 at the final answer. Okay, have we finished the question? The question was, how many feet up the tree did the squirrel climb? We got that answer. And then how far from the ground is the squirrel?
We can just add the 2 x and y.
Do we need to add x and y?
No, we just need to do y.
Good. So the total distance from the squirrel is y plus 2. Okay. The squirrel is, let's see, y plus 2, 74.194 feet, is 74.194 feet up in the air. Up in the tree. Or I guess I could say from the ground. Cool. All right. Okay. So, like I said, we're kind of limited to right triangle trigonometry, but that actually makes it easier because you know that that's the kind of situation that you're going to be dealing with. Okay. Let's talk about trigonometry and bearing. So write down trig and bearing, or just bearing. You remember that? So, when you go north 30 degrees east, what do you think that means? Mm-hmm. Or just like, or on like a compass, you know? Yeah, kind of. It's just a matter of like, which direction is it 30 degrees from?
Oh, okay. So you go up north 30 degrees from that.
There you go. Okay. So just a reminder, north, south, and then what? West, east? Okay. I just remember it spells we. Okay. Okay, so for north 30 degrees east, we would go north, and then we would rotate 30 degrees east. And so that would be, the bearing would put us on that line. My 30 degrees is a little too large. Somewhere in there. Cool? All right, so what if I said north 68 degrees west? Okay, so go up, but then go rotate 68 degrees west. So if 60 is like right here, 68 somewhere in here. Okay, and then what about south 45 degrees west? Okay, down and then 45 degrees to the left. So down and then. Are you ever going to have like south 110 degrees west? Why not?
Because then you could just say north.
Agreed. You would just say north otherwise, right? So that would be north 20 degrees. Yeah, or something, or actually 70 degrees. Yeah, okay. So, yeah, it's always going to be an acute angle, and so as far as just sketching it, that's all you got to be able to do. All right. A boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. The boat then travels at a bearing of south 48 degrees east for 18 miles. How far is the boat from the harbor entrance, and what is the bearing of the boat from the harbor entrance? Okay, so let's start writing down the situation. Leaves the harbor and travels, write down, leaves harbor at north 42 degrees east, and then 25 miles. That's how much it travels. Yeah? Then, and this is going to be very contrived because it's just like a sharp turn, like all of a sudden. But anyway, then travels at what? Degrees east for 18 miles. Okay. And then for your notes, write down distance from harbor and by distance from harbor, I mean straight line distance. And then bearing from harbor. Okay. We need to plan it out so we can know where to put the harbor. We're going to be traveling north. So we're going to be traveling north 42 degrees east, and then we're going to be traveling south, so then south and then 48 degrees east. So I do need to be able to start from down here because it looks like it's going to happen where it's going to be something like this. Okay. So what I want you to do is draw a, it could be just a vertical line, and we just put a spot for the harbor. Okay. We need to have a segment where we travel at north 42 degrees east for 25 miles. So north 42 degrees east, so if this is 90, 42 would be somewhere in here, yeah? So 42 degrees east for 25 miles. So I'm going to let that be 42, and then I'm going to let this be 25 miles. Okay. Now it says we're traveling, like from there, we turn and travel at south 48 degrees east, right? So what I would do is I would draw a dotted crosshairs, so you can kind of see your compass again. And from there, you want to travel south 48 degrees east. So south 48 degrees east, which means this angle right here is 48 degrees, and we want to travel that for what, 18 miles? Okay, now depending on the way that you drew this point right here looks like it could be either above where the harbor is or down below, right? Depending on how, your comparison on your 25 and 18, because we're just drawing, right? So that'll be interesting to see how that plays out. Okay? So my question is, how far is the boat from the harbor? We're trying to figure out that length right there, right? Well, what kind of trigonometry are we limited to? Okay, so do we have a right angle? Well, so here's what we got. I know that this is 42 degrees, right? Do you remember from geometry that if you have two parallel lines cut by a transversal, that alternate interior angles are the same? Yeah. Okay. So if that's 42, then this is also 42. So that's a right angle. Okay. Okay, which means that this is a right angle, which means we can use right triangle trig. So, actually, I don't have to use the trig, the sine, cosine, or tangent. I actually don't know any of the other angles inside the triangle, do I?
Yeah, you don't.
I don't. Right. But I can find it if I need to in a minute. All I need to know in order to find the third side is, because it's a right triangle, I can use what? I can use Pythagorean theorem. Yeah, if it's three sides of a right triangle. Okay, so the hypotenuse is x. 25 squared plus 18 squared equals x squared. Yeah? So 949 equals x squared. So square root of that equals x. And I get 30.806 if I round. Cool? Okay. All right. So that one is actually pretty, that's just straightforward, just using Pythagorean theorem. But here's my other question. It says, what is the bearing from the harbor to where the boat is right now? So let's explore that for a second. If depending on what angle I find, if this is my harbor, and this is here and this is here, if this is above, then it's going to be north something degrees east. Agreed? But if these two angles add up to more than, and by these two angles I mean this one and this one, yeah? If those two angles add up to more than 90, then that means that my boat is now below. So it was like up and then down. So then I would say if these two angles add up to greater than 90, then I know it's going to be a southeast bearing. Cool? I don't know what that is until I figure out what the angle is. Hey, hey. You want me to catch you up right quick on what we're dealing with?
Oh, yeah, sure.
Okay. So we're talking about bearing and right triangle trig, right? So we said if you've got a boat that travels from a harbor at north 42 degrees east for 25 miles, and then turns and travels at south 48 degrees east, the question is how far is the boat from the harbor? And because of alternate interior angles, right? This is 42, that's 42, and those two add up to 90, which means you have a right triangle. We can do Pythagorean theorem. And now what we're trying to do is we're trying to find the bearing of the boat from the harbor. So we're trying to determine, is it this or is it this? And the only way that we can do that is if we know these two angles and add them up. Okay? So what do you think? Michael, how do we find this angle right here? How do we find theta?
No, I think we have the hypotenuse here.
Okay.
And we know. Oh, we do know the adjacent, which is going to be half of x, right? No?
Well, think of it more like here's the right triangle. Yeah? And if you want an angle given two sides.
Right. Okay, so then in that case we know the two sides.
Yeah, in fact, like you said, we actually know all three sides, don't we?
Yeah.
We know 18, we know 25, and we know the square root of 949 to keep it accurate. Cool? So you can use any of the three trig functions that you want. But going ahead and just using the numbers that they gave us, this is opposite to that angle and that's adjacent. So we just use tangent. Cool? So I could say tangent of theta equals whatever what? 18 over 25? Okay, so now what do I do? There you go. Okay, so we take tan inverse. Tan inverse. We are in degree mode. So we're going to take tan inverse of 18 divided by 25. 35.754. So I get that that's 35.754 degrees. So what should we do now? Okay, good. So the idea is the bearing is going to be this angle right here. So we're going to add. Yeah, east. Yeah. No one's ever asked me that before, and I was like, yeah, it would just be east. Okay. So 35.754 degrees, and that is what, 77? That's 77.7, ooh, Jennifer. 77.754 degrees. So which situation is it? Is it? Good. We know that this angle is 77 point, what was it, 754? Okay. 0.754 degrees. So my final bearing is north east. Now, if you told me east something north, it's not wrong. We just always go from the north and the south first. Okay. All right. What do you think about that? Okay, let's do it again. You start hiking on a trail on a bearing of south 31 degrees east for 22.3 miles, and then turn onto a bearing of south 59 degrees west and hike for 2.8 more miles. How far are you from the start of your hike, and what is your bearing from the starting point? Where are we traveling? Which direction?
Southeast, and then you're going southwest.
So, do I need to start from like at the bottom or at the top of my?
Oh, it doesn't matter, right?
Well, I definitely don't.
Well, I guess if you're gonna let yourself badly to a line stop.
Yeah, okay. It does make sense though. If I'm gonna go south, then what you don't want to do is like you leave yourself this much space to work on your problem, and you start down here. You know. Okay. So I am gonna travel, and like I said, I like to give myself some kind of bearing, or some kind of crosshairs to start with. Like, so this is my starting point. I'm gonna travel. I don't even know if I gave myself enough space, but we'll see. South 31 degrees. Hello. South 31 degrees east. So 31 is kind of in here. Yeah. For how many miles? 2.3 miles. And now what do I do?
You go south 39 degrees west.
So then I do another little crosshairs. And south 59 degrees west.
59, can't read.
That's good. So 59 degrees west. For 2.8 miles? Okay, so tell me the angles I know.
Okay.
I'm going to zoom in. That didn't help. Is that just normal? Whatever. Okay. I see 4 different angles over here. I see this angle. I see this angle. I see this angle, and I see this angle. You see what I mean?
No, I see like 2. I see 1.
Let me draw it a little bit bigger. Okay. So 31 degrees, so somewhere in here. That's a little 2, whatever. So 31 degrees. And then south 59 degrees, or yeah, and then west. So and I did not keep that on a level. Okay. So I was talking about this one, this one, this one, and that one.
Well, we know that one, right?
Right, but I'm saying that those are 4 angles that are all kind of beside each other, right? Okay. And they all add up to what?
180.
180. So what angles do I know? I know the 59.
Well, the crosshair is like 90 degrees, right?
Which one?
Does the crosshair itself make 490 degrees?
Yeah, all those make 90.
So you just do 90 minus 59.
Okay, so you agree this is 31?
Yeah.
Okay. Yeah, And then what else?
You just do the geometric rules, right?
The what?
The geometric rules. So, should it be 59 again?
So the reason why it's going to be 5931 again is because this right here, this is an alternate interior with this one right here. Because you got 2 parallel lines cut by a transversal, so if that's whatever that is, that's the same. Okay, so this would also be 31, which would mean this is also 59.
Also, there's all the crosshairs in the parallel line.
Yeah, it definitely helps. Can we say that we have a right angle?
Yes.
And in fact, I didn't even have to really label these, as long as I know if I add up to 180 degrees and 90 degrees is being taken up by those two.
I will not need calculators from you.
Okay, all right. Okay. See ya. If 180 degrees and I can subtract 90, then I've got 90 left over. Yeah, but that's okay. We can have those. So I've got a right triangle. I didn't really draw it right, but that's okay. Ooh. If I can. That looks more right than before. Ah, well, whatever. Okay. 2.8 miles. And so we connect. Ugh. All right. The question is, it's very similar to the last question. How far are you from the start of your hike, and what is your bearing from your starting point? Okay. So do Pythagorean to find the this leg. All right. Let me erase all this. Have you already done it? Okay. So 2.3 squared plus 2.8 squared equals x squared. X equals 3.624 miles. Okay. So, all right. And then what is your bearing? Okay, yeah. So this is going to be, remember we always start with the south of the north direction, right? So in this case, it looks like we're going to be traveling south, and the question is like how many degrees west? Because I do believe that it crosses across the.
But in theory, like, it could.
Right, it could still be over there. So whatever I get for this angle right here, right? If it's more than 31, then I know it went a little bit to the right, or sorry, to the left. Yeah? Okay. So what do we got to do? And exactly what we need to know is this entire angle. Okay. If that angle is less than 31, then we subtract it from 31. Or we subtract, yeah, and we figure out how much is the difference. Because I guess what we're dealing with is the possibility of it being, it could be a little bit this way, or it could be what we have up here. So this is south something east, whereas this is potentially south something west, the way that I've drawn it. Okay, so what do we do? Okay. So tangent of theta. Okay. Theta equals tan inverse. Why did I say? I know. I don't know why I did that. Wait 1 second. 2.8 divided by 2.3. Say it again.
50.59.
Did it round up?
There's a 33934.
Okay. All right, so 50.599. So that means this angle right here is 50.599. What are we going to do now?
Over 31, you know, it's going to be south, something west. That's going to be the south 50.599 degrees west.
Are you sure?
What do you think? No, because we're, yeah, you just have to subtract 31 out of it.
There you go. Okay, I'm actually going to edit my picture for the notes just to make it a little bit more accurate then. Knowing that it's actually like 20 degrees or 19 degrees, right, that we're going to travel over, I'm going to add a little bit more length to that. So when I go from here to here, it's a little bit easier to see that this right here is the angle that I need. So there's theta. I need this angle right here. a different color. Theta 2. I'm going to change the thickness of the pen. All right, so theta 2, let's put Q2, equals 50.599 minus 31, which is what? 19.599 degrees. So my final bearing is south 19.599 degrees west. What do you think about that?
Pretty easy, just a lot of lines.
Yeah.
But maybe confused as well.
Yeah. So I guess when you draw it really small, it can make it kind of confusing. Okay. All right. Harmonic motion. And obviously that makes sense that with sine and cosine waves, we're talking about harmonic motion. Harmonic motion is the up and down, or the right and left, the wave. An object that moves in a coordinate axis in a simple harmonic motion is in simple harmonic motion if its distance from the origin d at time t is given by either distance equals a times cosine of wt or distance equals a times sine of wt. The motion is amplitude, absolute value of a, and the maximum displacement of the object from its rest position. The period of the motion is 2 pi divided by w, 2 pi divided by b, right? Where w is greater than 0, and when would you use sine versus cosine? Well, it depends on whether you start at like an extended or from rest, right? I guess when I think, like if I think about a coil, right? A spring, or something moving back and forth. One way that you could think I would use a cosine is, say you have a spring hanging from the ceiling, right? If you pull it to its maximum and then you release, then you're starting from like a maximum position, right? Now, what's going to happen to these waves? They will decay, right? So this is not perfect in this way. We would have to multiply it by some also function of like x, but we can just talk about their beginning motion. Okay. A weight on a spring is pulled 4 inches below its resting position and then released. The period of the motion is 1.2 seconds. Write an equation for the weight's simple harmonic motion. Like I said, this is problematic because it should decay. But we'll say as if for a short amount of time, very short. So what do you think? A weight on a spring is pulled 4 inches below its resting position and then released. The period of the motion is 1.2 seconds. Write an equation for the weight's simple harmonic motion. Is this d equals a sine or a cosine? Okay. So what is a?
4, right?
Because it's pulled 4 inches away from resting position, and then we just need to figure out the b.
Wait, well, what's t then? Is that time?
T is time. Yeah.
Okay. So for b, it's just 2 pi divided by 1.2.
There you go. 2 pi divided by well, we'll go ahead and I'll put 2 pi divided by w equals the period, which means 2 pi divided by the period equals w. 2 pi divided by 1.2. Now 1.2 we could rewrite as a fraction. We could say, what, 6/5? And then multiply by 5/6. That's whatever. Or we could just divide it. Leave it in terms of pi. Trying to decide what I care about.
5 pi over 3.
Yeah, it'd be 5 pi over 3, but if we did the decimal equivalent, I feel like it's not as accurate because yeah, we'll just do 5 pi over 3. However, wouldn't be wrong. What is the frequency of the weight?
What do you mean by frequency?
So frequency is like per time period, how much of the wave per time period. So if we're saying the period is 1.2 seconds, let's see, I want to make sure I say that correctly. Did I mention frequency on here? No, I did not. Let me make sure I say the right thing on what I want from that. I feel like frequency is how often it happens.
Frequency is the rate of
Yeah.
per meter second. 1 period.
Yeah, I feel like it's 1 divided by 1.2. But I want to make sure on that. Yeah, it's the amount of the cycle per time unit per second. So we have one wave every 1.2 seconds. Yeah. So one wave every 1.2 seconds. So that ends up being what? 5/6, because that's 6/5. 5/6 of a wave per second is the frequency. Yeah, so frequency is just 1 divided by the period. Cool. Okay. And that is all I have for you. I think I'm going to cut that down a little bit, though. We don't need to do all those. 637. I'm going to say skip. Some of these other ones are good. Let's see. I'll just, yeah. Skip those. Don't do that one. 49, 50, 56 through 60. Okay. Oh, I took off 5. That's something. Okay. All right. That's the end of that. Thanks for joining.